Okay. Am I audible?
Yes, sir.
Okay. So we have done with your centripetal force. Let us try to take one example better for this one. Say for example,
Sir, screen is not sharing.
screen is not shared. No.
Yes, sir.
Let us try to take an example for the centripetal force beta. Let's say for example, a string is been attached with a bob here right now, and this is been swinging. So the forces acting in the equilibrium, can you tell me what beta? One is the weight of the body in the downward direction,
mg
and another is the tension in this one.
north.
This is your
Yes,
T is
attention.
there. So when Bob is at rest, when Bob is at rest, isn't it? This T will balance your weight. So T will be equal to M into G,
Yes, sir.
isn't it? So the Bob will be at rest. When you make a circular path right now for this one, that means when you give certain mark and this is moving along the arc like this, at that time will T will be greater than of your mg. Second condition right now, if T is greater than of your weight of your mg, that means what? Net force, or we can say an unbalanced force, act towards the center. Unbalanced force act towards center, which provides centripetal force, which provides you the centripetal force. That means if capital T is more beta, this particle will be trying to move in the circular path. So what is the force which is moving toward the center? This is a center O. This is T. So how do you write the equation beta? T minus opposite force is M into G is equals to M into your centripetal acceleration. ఇది ఎలా వచ్చింది తెలుస్తుంది కదా, from Newton's law relation. F net is equals to mass into acceleration.
Acceleration.
The
Yes, sir.
force acting on the body is T minus of your mg. T minus of your mg, that is equals to M into your AC. So that means if I substitute the values and simplify it, so this is a T minus of your mg is equals to M into centripetal acceleration is V square divided by radius. Radius here is nothing but length, but I can write that one as M into V square by your L, because here radius will be equal to your L. Because when it makes here the circular path from O to the point of where the bob is been attached, that will be the radius. That radius is nothing but equal to the length. So that is the reason it can
Yes,
able
sir.
to make a circular path right now. So at that time the equation what I can write here is nothing but of your T minus of your mg is equals to M into V square divided by your R, or T is equals to M minus of your mg is equals to M into V square by your L. Or I can write here T is equals to this minus if I'm taking on this side. So this will become for me mg plus M into V square by your L. Can I write like this?
Yes, sir.
So this is your tension. Sound ತಗೊಂಡಿದ್ದೀನಿ.
Sir?
Next one is your sound తగ్గించుకుంటాను, వాయిస్ వస్తుంది.
Oh.
Concept to find velocity and tension. Velocity and tension at any angle, any angle theta. So we need to calculate your velocity and your tension at any angle theta in circular path, or circular motion. Okay, see that.
సార్ ఇప్పుడేం రావట్లేదు కదా సార్?
వచ్చింది, చాలా వస్తుంది.
అది ఈ ల్యాప్టాప్ది సార్, అంటే సార్ నేను అంటే
ఇంతకుముందు
మ్యూట్
తగ్గించింది.
చేసుకుంటాను. యా ఇందాక ఇట్లా చేయబెట్టాను సార్.
మ్యూట్
అంటే
చేసుకోండి సార్.
ఎస్ సార్, నేను మ్యూట్ చేసుకుంటా, అవసరం ఉన్నప్పుడు ఇట్లా అంటే ఆన్ చేస్తాను.
Okay, see here beta, see this is your bob which is at the center. The length of this one is nothing but of your L beta. From here to here, this is your length of your L, and here one small bob is attached, and it is taken from here to the angle, making an angle theta to a new position somewhere here. Okay, by giving it certain initial velocity, say for example u. Here the initial velocity is u, and when it comes at this position, the velocity will become for me how much? Something v velocity at any angle theta is equal to how much? For this bob, I have given an initial velocity u. It will make an angle theta and goes to a new position, isn't it? So when it is at a from center to this position beta, the length of this one is nothing but of your L. So theta is equals to 0. I can write at theta is equals to 0. That means when it is vertical, v will be equal to how much beta? V is equals to your u. That means initial final velocity will be equal to how much? That means there's a theta is equals to 0. A theta is equals to some theta. V is equals to v final is equals to your v theta. This we need to calculate. Tension we need to calculate. Tension at certain angle theta will be equal to your how much? Okay. Now see what are the forces acting on this body. If I'm writing the forces acting on the body, one is the weight of the body acts in the downward direction. That is nothing but of your mg in the theta is equals to 0. And another angle which is acting in the upward direction is nothing but of your tension. So at this position right now, the tension will be in the upward direction. So when it comes to right now here, somewhere at this position, the weight of the body is no doubt mg in this direction. And if I resolve that one into the components beta, now this one is right now here, this is making an angle theta, and here also will get one component in this direction. So if I'm resolving that, so here this will become for me your mg into your cos theta, and here in the downward direction, this one is mg into your sin theta. Tension will be developed in the string, so that will be the tension T. And here it is the velocity of your theta. So tension here it is nothing but at your some angle theta. So T theta will be balancing your mg. Now tell me what is the tangential force which has been acting on this body? If I'm writing the first point, tangential force. Tangential force. Tangential force represented by your ft అనుకుందాం. ft is equals to along the tangent, this is the force which has been acting, that is mg into your sin theta. So that is equals to your mg into your sin theta as a tangential force. In the same way, tangential acceleration. So if I'm writing, the next one is of your tangential acceleration. So what will be the tangential acceleration beta right now? G value is in the downward direction. So along this one, it will be your g into your sin theta. So this will be tangential acceleration is equals to g into your sin theta. And you just remove in the place of your ft, you take m into a. Mm gets cancelled, so we'll get the tangential acceleration. At is equals to g into your sin theta. E formula I'm writing here itself, you see. So here it is your m into your at is equals to m into g into your sin theta from this one. So this m gets cancelled. So tangential acceleration, I'm getting it as of your g into your sin theta. Okay. The third one is about your radial acceleration. So if I'm talking about your radial acceleration, so a radial is equals to your initial velocity at that point will be equal to how much beta? V theta square divided by r. R is nothing but equal to L. So V is equals to at certain position, AR is equals to this much. That means at angle theta, unbalanced force R, unbalanced force will be equal to how much beta? C. One force is toward the center, opposite force is mg into sine, mg into cos 30. So I can write this one as of your t theta minus mg into your cos theta will be equal to your m into your v theta square divided by your L, isn't it? So this is the tension. So tension theta, if I'm taking on other side right now, I can write this one as of your tension will become for me t theta will be equal to, this will become for me your mg into your cos theta, mg into your cos theta plus of your m into your v theta square divided by your L. So this is the tension at any angle theta. So this is your very important relation. You need to remember tension at any angle theta in a circular path is calculated by the formula T is equals to mg cos theta plus m into v theta square divided by your L. Now see here, when this body is going from here to here, if you see it carefully, yeah, this is gone to this position right now. So from here to here, if I'm writing this relation, so this is the horizontal position to which it is been coming. Another. That means from the ground, it has been raised this much of distance. Another. So this much of distance it has been raised. ఇదెంత అవుతుంది? ఇది h. అంతే కదా?
Yes.
Now if I am writing this one in terms of length, if this is your L beta from here to here, if this is your L, if you resolve it right now for the given condition, so this is making here angle of 90 degrees and this will be equal to your how much beta? If this is your h, if this is your h, this will become for me L minus of your h. ante kada? From C to this position.
Yes.
This one is nothing but of your, this is nothing but of your L minus h, and here to here this is h, and total is nothing but L. So if I'm removing h from this L part of relation, so it is your L minus of your h part of relation. That means from the figure I can write cos theta is equals to, from the figure cos theta is equals to how much? L minus h divided by your L. ante kada? This is L minus h and this one is nothing but of your L, and this is your theta. Antena? Ante
Yes.
L minus h will be equal to how much? L minus h is equals to L into your cos theta. That means from this one I can write the value of your h beta. H value will be equal to how much for me? H is equals to L common into 1 minus of your cos theta. This is very important one. So h will be equal to how much for me? L into your 1 minus of your cos theta. Now we need the velocity kada. So as we need the velocity right now, I can use the relation kinematic equation as h is equals to L into 1 minus of your cos theta. So from kinematic equation, v square minus u square is equals to 2g into your h. Velocity at any angle is nothing but theta. That is nothing but of your u square initial velocity. That is equals to your 2 into acceleration due to gravity are going against gravity minus g into h is nothing but equal to how much for me or h. H value is equals to how much we got this one. So I can substitute that value there right now. So this will become for me v theta square is equals to, this will become for me u square minus of your 2g into your h. H is how much for me? Your L into your 1 minus of your cos theta. So velocity will become for me v theta is equals to, this one is under root of your, this one is nothing but of your u square minus of your 2g into your L into 1 minus of your cos theta. So this is the velocity at any angle theta in a circular path. These two are the actual very important equations which you will regularly be using in the throughout the chapter whenever you talk about any circular motion. So velocity at any angle theta is calculated by the formula v theta is equals to under root of u square minus 2g into your L into 1 minus cos theta, and tension is calculated by the formula T at theta is equals to your mg into your cos theta plus of your m into your v theta square divided by your L part of relation. Is it clear?
Yes, sir.
So these are the relations you need to remember better. So you just go through these notes today in detail, and we'll start doing the applications of this one in the tomorrow section of a class. That is turning of your rods, friction, angle of banking part of relation, death wheel rotor. There are a lot of applications, conical pendulums, horizontal
Yes, sir.
circular
Actually,
motions.
yesterday in class we started with I mean, like sir explained cone and hemispheral, like
Uh,
slipping of a mosquito
yeah,
or
that we'll
insect.
try to do all in the tomorrow session of a class. Just okay.
Yes, yes,
Okay, beta. Bye.
yes, sir. Thank you, sir. Bye, sir.